Hello, in this lecture we'll find out the ratio between two radii. In the drawing we have a big circle. Inside this big circle we have two small circles. We know that the radius of this circle is b and the radius of the smaller circle is a. In addition, we know that inside the biggest circle we have a right triangle ABC that is actually partially located inside the biggest circle. The length of side AB of triangle ABC is 5 units. Side BC equals to 12 units in its length. We also know that AN equals to NC. Our mission is to find out the ratio between the radii of those two circles, that is to say the ratio of B over A. So first of all, we'll implement the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem, in the right triangle ABC, my PT is a relation from Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle is AC, therefore the square of the hypotenuse is AC squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AB squared plus BC squared. Repeat again. According to the Pythagoras theorem in the right triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25. Plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 169. So BC is 12, therefore BC squared is 12 squared, that is 144. Therefore, in total, AC squared equals to 25 plus 144, that is actually 169. Here we take out of this equation and we get that AC equals to the square root of 169, that is 13. So we found out that the length of the hypotenuse AC of the right triangle ABC is 13 units. Because of the fact that AN equals to NC, it means that at point M, the hypotenuse is bisected into two halves. The first half is AN and the second half is NC. So AC over 2 is 13 over 2, that is equal to the first half of the hypotenuse AC is AN and the second half is NC. And of course, here AN equals to NC. Each half equals to 13 over 2. So here, the second half NC, it is equals to 13 over 2 units. In the next step, I will present to you a new rule, rule number 8, and we'll implement rule number 8 in our drawing. According to rule number 8, the radius of a circle that is blocked by a right triangle is equal to R equals to A plus B minus C over 2. We have the right triangle ABC, and get ABC equals to 90 degrees, side AB equals to units in itself, side BC equals to B units in itself, and finally the length of the hypotenuse AC is C. So according to rule number 8, we can find out the value of R only by knowing the side lengths of the right triangle that blocks this circle. That is to say, the radius R will be equal to A plus B minus C over 2. So it is, the radius R will be equal to the sum of the side lengths of the perpendiculars of the right triangle minus the length of the hypotenuse over 2. A plus B minus C over 2. We can implement rule number 7 in our drawing. Because in our drawing we have the right triangle ABC blocks this circle. The radius of this circle is A. According to rule number 8, we get that the value of A will be equal to sum of the side lengths of the right triangle ABC. That is to say, it is AB plus BC. The lengths, sum of the lengths of the perpendiculars, AB plus BC, minus the hypotenuse AC over 2. Repeat again, according to rule number 8, we get that the radius A will be equal to AB plus BC minus AC over 2. So the radius A of this circle that is blocked by the right triangle ABC will be equal to AB is 5 according to what is given as the question, BC is 12 according to what is given as the question. We just right now found out that the hypotenuse AC equals to 13, so it is minus 13 over 2. So we found out that the radius A equals to 5 plus 12 plus 13 over 2. 5 plus 12 is 17, and 17 minus 13 is 4, and 4 over 2 is 2. So we found out that the radius A equals to 2 units. The radius A here and therefore the radius A is equal to 2 units. In the next step, we define the center of this circle as P. We define the center of this circle as Q. And finally, we define the center of the bigger circle. This point is O. We define the point of tendency of tangent AB with this circle as T. We join points P and T together by a straight line. Point P is the center of the circle, point T is the point of the circle itself, therefore PT is the radius of the circle that is equal to 2. The radius PT is drawn to point T, that is the point of tendency of tangent AB with the circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we define the point of tendency of tangent BC with this circle as N. We join points P and N together by a straight line. Pn is the radius of this circle that is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle, and therefore tangent BC will be perpendicular to the radius NP. This is to say, this angle will be equal to 90 degrees, and this angle also equal to 90 degrees. Angle ABC is also close to 90 degrees because the triangle ABC is a right angle. So inside quadrilateral TPBN we have 1, 2, 3 right angles. And therefore the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So in quadrilateral TBPN we have 4 right angles. Any quadrilateral that has 4 right angles must be this rectangle, if not a square. So we relate to quadrilateral TBN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say PN equals to TB, but PN is 2, therefore TB must be also equal to 2. Likewise, in rectangle TPBN, TP equals to BN, but TP is 2, therefore BN must be also equal to 2. So actually, quadrilateral TPBN is not a rectangle but a square because all of its sides are equal to each other. So here, side BA equals to 5 units. The length of BA is 5, the length of BT is 2, therefore TA equals to BA minus BT. Again, TA equals to BA minus BT. So BA is 5, BT is 2, 5 minus 2 is 2, so AT equals to 3 units in its length. And here we have rule number 2 that states that the lengths of two tangents from a common external point to a circle are equal. So here we have the common external point A. For the common external point A, we have two tangents to the circle, tangent AT and tangent AM, and according to rule number 2, they are equal to each other. That is to say AT equals to AM, but AT is 3, therefore AM must be also equal to 3. We have already found out that AM equals to 13 over 2. AM equals to 3, therefore AN minus AM equals to MN. Again, AN minus AM equals to MN. So I write it down. AN minus AM equals to MN. AN is 13 over 2. MN is 3. Here we multiply minus 3 by 2 and then we divide it by 2 in order to have a common factor of 13 over 2. So 13 over 2 minus 3 times 2 is minus 6 over 2. 13 over 6 is 7, so in total this expression equals to 7 over 2. That is to say we found out that MN equals to 7 over 2 units in its length. This line segment MN is equal to 7 over 2 units. Okay, in the next step I present to you a new rule and we'll implement the new rule in our drawing according to rule number 7. If a line segment is drawn from the center of a circle bisect the chord, then the line segment is also perpendicular to the chord. The center of this circle is here at point O. From the center of the circle we draw line segment OM on chord AB that bisects the chord. That is to say AM equals to MB. So whenever you draw from the center of the circle line segment that bisects the chord, then it will be also perpendicular to the chord. The line segment OM will be perpendicular to chord AB. Again, because of the fact that OM bisects chord AB, that is to say we know that AM equals to MB, therefore OM will be also perpendicular to AB. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees. according to this rule, rule number 7. So we can actually implement rule number 7 in our drawing. Point O is the center of the bigger circle. We join points O and N together by straight line. ON is the line segment from the bigger circle that bisects chord AC. Why ON bisects chord AC? Because of the fact that AN equals to NC. And whenever you have from the center of a circle line segment that bisects the chord, then the line segment must be also perpendicular to the chord. That is to say, ON must be also perpendicular to AC. Because of the fact that ON bisects AC, therefore ON must be also perpendicular to AC according to rule number 7. So ON perpendicular to AC, that is to say, means that this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 7. I write it down here. It's line segment ON is perpendicular to tangent AC. From one side, but from the other side we know that point Q is the center of the circle, point N is the point of the circle itself, therefore QN is the radius of this circle. The radius QN, this radius is drawn to point N, that is the point of tendency of tangent AC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. So we found out that the radius QN is also perpendicular to tangent AC. We can write here that the radius QN is also perpendicular to tangent AC. And from the fact that ON is perpendicular to AC and QN is also perpendicular to AC, we will derive that point O, that is the center of the biggest circle, must lie on the radius QN. This is point O. Point O must lie on this radius QN. Why? Because ON is perpendicular to AC at point N, but QN is also perpendicular to AC at point N. Suppose that point N is not located in QN, suppose that this point O is not located on the radius QN, that is to say, for example, if point O is located here, and we join points O and N together, then it will never create angle of 90 degrees with AC. This angle will be bigger than 90 degrees, and the other angle will be smaller than 90 degrees. Suppose that point O is here, and we join points O and N together by straight line. Again, if we join points O and N by straight line, this angle must be less than 90 degrees, and the other angle must be more than 90 degrees. It will never create, if point O is not located on QN, ON will be never perpendicular to AC at point N. So point O must be located in QN in order that ON will be perpendicular to AC. Therefore, point O must be located on the radius QN. That if point O is located in QN on the radius QN, it means that QON is one straight line. QON is one straight line. So we know that QON is one straight line. At this point, the circle touches the bigger circle. We define the touching point as U. and then we go perpendicular tangent VW, that will be tangent at point U to both circles, to this circle and to the biggest circle also. This is tangent VW, that is tangent to both circles at point U. Point U is the point of tendency to both circles. So here we have point Q is the center of this circle, point U is the point of the circle itself, therefore QU is the radius of this circle that is on to point U. Therefore tangent VW will be perpendicular to the radius UQ. If VW is perpendicular to UQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. So we can write down that QU is perpendicular to tangent VW. The radius QU is perpendicular to tangent VW. In addition, point O is the center of the biggest circle. Point U is the point on the biggest circle itself. This is exactly the definition of a radius. So OU is the radius of the biggest circle that is on to point U. It is on to point U, that is the point of tendency of tangent VW with this circle. And whenever you have a radius that is on to the point of tendency, then tangent VW will be perpendicular to the radius UO. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. So we can write down that OU is also perpendicular to tangent VW. OU is perpendicular to tangent VW. The radius OU is perpendicular to tangent VW. And from this two equations, QU is perpendicular to the VW, and OU is also perpendicular to VW. We will derive that points O, Q, U, the 3 points are located on the same straight line, or now this line segment is one straight line. Repeat again, points O, Q, and U, they are one straight line from one side, but we already found out that QON is also one straight line. QON is one straight line, and OQU is one straight line. Therefore, in total, NQU must be also one straight line, and QU also must be a straight line. If NQU is a straight line, then NU is also a straight line. NU is a straight line. But NU, this line segment NU or UN touches the circle at points U and N, therefore it is a chord. NU or UN is a chord that passes for point U, that is the center of the circle, and any chord that passes for the center of the circle must be the diameter of the circle. Therefore, we found out that, in conclusion, that UN is the diameter of the circle. I'll write it down here. UN is the diameter of the circle. But we also know that the diameter of any circle is twice as long as the radius, and the radius of this circle is b, therefore the diameter must be equal to 2b. So the diameter UN equals to 2b. UN equals to 2b. in the next step, we join points O and P together by a straight line. Point O is the center of the biggest circle, point P is the center of the smaller circle. OP is the straight line that connects the centers of the biggest circle with the smaller circle. The smaller circle touches the biggest circle here at this point. We define the point of tendency as point S. So the smaller circle and the biggest circle have an internal notch between them at this point, point S. That is to say, they are touching each other internally at point S. So again, in the center, the straight line that connects the centers together is the straight line OP. The touching point here is point S. We have here all number 9, according to all number 9. The two circles touch each other internally, then the straight line that connects their centers together must pass for their touching point. So in this drawing we have an internal notch between those two circles, that is to say they are touching each other internally at point P. The center of the big circle is here at point O, the center of the small circle is here at point N. And the straight line that connects their centers together is the straight line OM. And according to this rule number 9, the straight line OM must pass for point P. If OM must pass for point P, it means that OMP is one straight line. Okay, OMP is one straight line. We can implement rule number 9 in our drawing. Again, the smaller circle touches the bigger circle here at point S. And the straight line that connects their centers together is the straight line OP. According to rule number 9, the straight line OP must pass for point S, that is to say OPS is one straight line. According to rule number 9, OPS is one straight line. Line segment OPS is one straight line. Okay, according to rule number 9, of course. So, if OPS is a straight line, then OS is also a straight line. OS is a straight line. And of course, because of the fact that OPS is one straight line, it means that OS or SO minus SP equals to PO. Again, SO minus SP equals to PO. So I write it down, SO minus SP equals to PO. It again, SO minus SP equals to PO. What is the definition of the straight line SO? The straight line SO starts from the center of the biggest circle and ends at point S, that is the point on the biggest circle itself. This is exactly the definition of a radius. So OS is the radius of the biggest circle, that is equal to X. So we substitute OSO, it is the same by X minus SP. What is the definition of line segment SP? It starts from point P, that is the center of the circle, and ends at point S, that is the point on the circle itself. This is exactly the definition of a radius. So SP is the radius of this circle, that is equal to 2. So now we substitute SP by 2. And finally found out that PO equals to X minus 2. PO equals to X minus 2. Again, this line segment PO equals to X minus 2 units in its length. In the next step, we will extend the perpendicular ON by a straight line. ON is of course a straight line. When you extend the straight line by straight line, the result is a straight line. So this is a straight line. If you focus on this side of the straight line ON, or the extended ON at point N, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have this side of the extended ON at point N, we have this angle that is equal to 90 degrees plus the missing angle. In total it must be equal to 180 degrees according to the rule that I mentioned. Therefore the missing angle here must be equal to 90 degrees. So this angle equals to 90 degrees according to the rule that I mentioned. We know that AC is perpendicular to the small circle at point M. Point M is the point of tendency. We join points P and M together by a straight line. P is the center of the circle, M is the point of the circle itself, therefore PM is the radius of this circle that is equal to 2. The radius PM is drawn to point M, this is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius MP. If AC is perpendicular to MP, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. In the next step, we will do a construction. We will draw perpendicular on the radius PM at point P. Again, we will draw perpendicular on the radius PM at point P. So, actually, this angle equals to 90 degrees according to our construction. Then we extend the perpendicular until it touches the extended straight line ON. And we define the touching point as T. In this way we created quadrilateral PT and M. In this quadrilateral PT and M we have 1, 2 right angles, therefore the fourth angle must be equal to 90 degrees. Inside quadrilateral PT and M we have 4 right angles, therefore quadrilateral PT and M is a rectangle. You know the opposite sides of a rectangle are equal to each other. That is to say MP equals to NT, but MP is 2, therefore NT must be also equal to 2. Likewise, in the rectangle, in the same rectangle MNPT, MN equals to PT, but MN is 7 over 2, therefore PT must be also equal to 7 over 2. We define the length of line segment NO as edge. So in the next step, we'll implement the Pythagoras theorem on the right green triangle PTO. So we copy the right green triangle PTO in a new page and we will implement on it the Pythagoras theorem. We just right now found out that PO equals to x minus 2. Here the hypotenuse PO equals to x minus 2. This is the right triangle of PT. We just right now found out that PT equals to 7 over 2. This is side PT. What is the length of OT? From the drawings it's very easy to see that OT equals to ON plus NT. OT equals to ON plus NT, that is to say, OT equals to ON, that is H, plus NT, that is 2. So in total, OT equals to H plus 2. If this side OT equals to H plus 2. So here we'll implement the Pythagoras theorem by PT's evaluation from Pythagoras theorem in this right triangle of PT. According to the Pythagoras theorem, in the right triangle of PT, PO square equals to PT square plus OT square. Repeat again. Come into the Pythagoras theorem. The right triangle of PT, PO square equals to PT square plus OT square. PO is x minus 2, therefore PO square is x minus 2 square. And it is equals to PT square. PT is 7 over 2, therefore PT square is 7 over 2 squared, that is 49 over 4, plus OT square. OT is h plus 2, therefore OT square is h plus 2 square. So if we're going to find out that x minus 2 square equals to 49 over 4 plus h plus 2 square. Here we'll open the brackets on both sides of the equation and you get that x minus 2 square equals to x square plus 4 minus 4x, and it is equals to 49 over 4 plus h plus 2 square is h square plus 4 plus 4h. In the next step, we join points O and C together by a straight line. Those 2 points, O and C. What is the definition of the straight line OC? Point O is the center of the biggest circle, point C is the point of the biggest circle Z. This is exactly the definition of a radius. OC is the radius of the biggest circle, that is equal to x. ON equals to h according to our definition, and we already found out in the beginning of the lecture that NC equals to 13 over 2. This is the right triangle, this angle equals to 90 degrees. So we'll implement the Pythagoras theorem on the right triangle ONC. So we'll copy the right triangle ONC in the new page and we'll implement on it the Pythagoras theorem. So actually, this is the right triangle ONC that they copied from the original drawing. Now we implement on this right triangle the Pythagoras theorem. According to the Pythagoras theorem, in this right triangle ONC, OC square equals to NO square plus NC square. Okay, again, OC square equals to NO square plus NC square. So OC is x, therefore OC square is x square. That is equals to NO square. NO is h, therefore NO square is h square plus NC square. NC is 13 over 2, therefore NC square is 13 over 2 square. That is 169 over 4. So in total we found out that x square equals to h square plus 169 over 4. Therefore we can substitute x square here by h square plus 169 over 4. We'll do it now and we'll get that x square is h square plus 169 over 4 plus 4 minus 4x. It is equals to 49 over 4 plus h square plus 4 plus 4h. So here we have h square on both sides of the equation, so h square will get cancelled. We have 4 on both sides of the equation, so 4 also will get cancelled. And in this side of the equation we left only with 169 over 4 minus 4x, that is equals to 49 over 4 plus 4h. Here we will subtract 49 over 4 from this equation, and we get that 169 minus 49 over 4 minus 4x equals to 4h. Here we add 4x to this equation, and finally we get that here we have 169 minus 49, it is 120, so in total this expression equals to 120 over 4 minus 4x equals to 4h. Here we add 4x to this equation, and we get that 120 over 4 is 30, so 30 equals to 4x plus 4h. Here we'll take 4 as a common factor for those two expressions, and we get it inside the brackets. We will have x plus h equals to 30. Here we'll divide this equation by 2 and get that 30 over 2 is 15 equals to 4 over 2 is 2 times x plus h. Here we'll divide this equation by 2 and finally we get that x plus h equals to 15 over 2. X plus h equals to 15 over 2. So what is the length of line segment UN? This line segment UN. From the drawings it's very easy to see that UN equals to UO plus ON. That is to say UN equals to UO, that is x, plus ON, that is h, so in total UN equals to x plus h. So you can argue that UN equals to x plus h from one side, but from the other side we have already found out that UN UN equals to 2b. Then I know that UN equals to 2b. UN equals to 2b. And from those two equations, UN equals to x plus h and UN equals to 2b, we will derive that x plus h equals to 2b. But we already found out that x plus h is also equals to 15 over 2, so we can write here that x plus h equals to 15 over 2. And from this equation, 15 over 2 equals to x plus h equals to 2b, we will derive that 15 over 2 equals to 2b. Here we divide this equation by 2, and we get that b equals to 15 over 2 over 2 is 15 over 4. So the radius of this circle b, it is equal to 15 over 4 units. We have already found out that the radius of this circle a is equal to 2. Here a equals to 2, and b over a is equals to b, that is 15 over 4 over a is 2, so it is over 2. 15 over 4 over 2 is 15 over 8. In terms of numbers, it is 1.875 without units. Repeat again. The answer to this question is that the ratio between the two radii of those two circles, b over a, is equals to either 15 over 8 or in terms of numbers, it is equal to 1.875 report units. Okay, in the next step, I will summarize the lecture. In this lecture, I found the ratio between the radii of those two circles, that is to say, between the ratio between the radius of this circle to the radius of this circle. The radius of this circle is B and the radius of this circle is A, so I found the ratio of B over A. So in the drawing we have a big circle. Inside this big circle we have two smaller circles. We know that again the radius of this circle is B and the radius of this circle is A. In addition, we know that the biggest circle is partially contains the right triangle ABC. This angle ABC equals to 90 degrees. Side AB equals to 5 units in its length. Side BC equals to 12 units in its length. And we also know that AN equals to NC. Again, our mission is to find out the ratio of B over A. In order to find out the ratio, we implemented the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. Again, AC squared equals to AB squared plus BC squared. So AC squared equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. 25 plus 144 is 169, so in conclusion, we found out that AC squared equals to 169. We took a root out of this equation and we found out that AC equals to the square root of 169, that is 13. That is to say, the hypotenuse of this right triangle AC equals to 13 units. And because of the fact that AN equals to NC, according to what is given as the equation, it means that at point N, the hypotenuse AC is bisected into two halves. The first half is AN, the second half is NC. That is to say, AC over 2, that is 13 over 2, equals to the first half, that is AN, and the second half is NC. So AN equals to NC equals to 13 over 2. Each half equals to 13 over 2. And the second half, NC equals to 13 over 2. The first half, AN also equals to 13 over 2. In the next step, I presented to you rule number 8, and we implemented rule number 8 in our drawing. According to rule number 8, the radius of a circle that is blocked by a right triangle is equal to R equals to A plus B minus C over 2. The meaning of rule number 8 is that we can find out the radius of a circle that is blocked by a right triangle only by knowing the side lengths of the right triangle. That is the meaning of rule number 8. And according to rule number 8, if we add the perpendiculars to each other and we subtract the rest of the hypotenuse from the sum of the perpendiculars and we will divide it by 2, we will find out the radius of the circle that is blocked by the right triangle ABC. Okay, that is to say, the radius of this circle, R, that is blocked by the right triangle ABC, will be equal to A plus B minus C over 2. Okay, that's a very simple rule that we can implement in our drawing. Why? Because in our drawing we have the right triangle ABC that blocks this circle. The radius of this circle is A. So we can find out the radius A only by knowing the side lengths of the right triangle ABC, and we know the side lengths of the right triangle ABC, so we can implemented rule number 8. So the radius of this circle A that is blocked by the right triangle ABC will be equal to AB plus BC minus AC over 2. Repeat again. So rule number 8. The value of A, the graph of A will be equal to AB plus BC minus AC over 2. AB is 5. AB is 5. BC is 12, and we just found out that AC is 13. So in total, this expression equals to 5 plus 12 minus 13 over 2. 5 plus 12 is 17, 17 minus 13 is 4, and 4 over 2 is 2. So finally we found out that the radius of this circle A equals to 2 units. The length of the radius A is 2 units. Okay, then we define the center of the circle is Q, we define the center of the circle is P, and we define the center of the bigger circle as O. We define the point of tendency of tangent AB with this circle as T. Then we join points T and P together by a straight line. What is the definition of line segment PT? Line segment PT starts from point P, that is the center of the circle, and then the point T, that is the point of the circle itself. This is exactly the definition of a radius. Therefore, TP is equals to A, and A equals to 2 units. It is the radius of the circle. So the radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. That is to say, this angle will be equal to 90 degrees, and this angle will be equal to 90 degrees. Likewise, we define the point of tendency of tangent BC with this circle as N. We join points P and N together by a straight line. Pn is the radius of this circle is equal to 2. The radius Pn is drawn to point N. That is to say, it is drawn to point N, that is the point of tendency of tangent BC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NP. That is to say, this angle equals to 90 degrees, and this angle equals to 90 degrees. So inside quadrilateral PTBN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees plus the fourth angle. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees. Therefore, the quadrilateral TBNP that has 4 right angles must be a test rectangle in flat square. So we relate to quadrilateral TPBN as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, TP equals to BN, but TP is 2, therefore BN must be also equal to 2. Likewise, in rectangle TPBN, PN equals to TB, but PN is 2, therefore TB must be also equal to 2. So finally we found out that quadrilateral TPBN is not a rectangle but a square, because all of its sides are equal to each other. So we know that TB is 2 and AB is 5. AB minus TB is 80. Again, AB minus TB is 80. AB is 5, TB is 2, 5 minus 2 is 3, so 80 is 3. Then we have here rule number 2, that the lengths of two tangents from a common standpoint to a circle are equal. From the common standpoint, point A, we have two tangents to the circle, tangent AT and tangent AM. According to rule number 2, they are equal to each other, but AT is 3, therefore AM must be also equal to 3. We know that AN equals to 13 over 2. AM is 3, so AN minus AM is MN. Again, AN minus AM is MN. I'll repeat again. AN minus AM is MN. AM is 13 over 2 minus AM, that is 3. We multiplied minus 3 by 2 and then we divided by 2 in order to have a common factor with 13 over 2. So it is 13 over 2 minus 3 times 2 is minus 6. 13 over 6 is 7. So in total, found out that Mn equals to 7 over 2. This line segment Mn is equal to 7 over 2 units in its line. Okay, then I presented to you rule number 7 and implemented or number 7 in our drawing. According to rule number 7, if a line segment that is drawn from the center of a circle bisects the chord, then the line segment is perpendicular to the chord. The center of the circle is here at point O. From the center of the circle, that is to say from point O, we draw the line segment OM that bisects chord AB. That is to say AM equals to MB. And because of the fact that OM bisects AB, OM will be also perpendicular to AB. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees. Whenever you have a line segment from the center of the circle that bisects the chord, it is not only bisect the chord, but it will be also perpendicular to the chord. And because of the fact that OM bisects chord AB, OM will be also perpendicular to AB. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule number 7. We can implement rule number 7 in our drawing. Why? Because in our drawing, point O is the center of the bigger circle. We join points O and N together by a straight line. Line segment ON bisect chord AC. Why? Because AN equals to NC. And whenever you have a line segment from the center of a circle that bisects the chord, it is not only bisect the chord, but it also will be perpendicular to the chord. That is to say, line segment ON must be also perpendicular to chord AC. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. Okay, so we can write down here that line segment ON is perpendicular to tangent AC. Likewise, we join here points, Q. Point Q is the center of the circle, point N is the point of the circle itself, therefore Qn is the radius of the circle. The radius Qn is drawn to point N, that is the point of tendency of tangent AC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So I can find out that Qn, the radius Qn of this circle is also perpendicular to tangent AC. So we can write here that Qn is also perpendicular to tangent AC. And from those two equations, ON is perpendicular to AC and Qn is perpendicular to AC, we derive that point O must lie on Qn. This is point O, that is the center of the bigger circle. This point O must lie on this radius Qn. Otherwise, if point U doesn't lie on Qn, it means that wherever you will put point O that is not on Qn, it will not create 90 degrees with AC. You can try and see that whenever you put point O on this circle, here ON will never create 90 degrees with AC. Point O must lie on Qn in order to create 90 degrees with AC. So point O must lie on Qn. Point O must lie on Qn. So QON is one straight line. Line segment QON is one straight line. All those 3 points lie on the same straight line, QO and N. Likewise, here we have point U is the point of tendency of this circle with the biggest circle. We draw tangent VW, that is tangent to both circles and point U. Then we have here point Q is the center of the circle. Point U is the point of the circle itself, therefore QU is the radius of this circle that is drawn to point U, that is the point of tendency of tangent VW with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UQ. Okay, so you can write here that the radius QU is tangent to VW. The radius QU is tangent to, is perpendicular, the radius QU is perpendicular to tangent VW. likewise, we have point O is the center of the biggest circle. Point U is the point of the biggest circle itself. So this is exactly the definition for radius. So OU is the radius of the biggest circle that is equal to x according to our definition. The radius OU is drawn to point U, that is the point of tendency of tangent with W with the biggest circle. And whenever you have a radius that is drawn to the point of tendency, then tangent with W will be perpendicular to the radius UO. So we found out that the radius OU is also perpendicular to VW. Again, the radius of the biggest circle OU is also perpendicular to VW. And on those two equations, QU is perpendicular to VW and OU is also perpendicular to VW. We will derive that QOU is one straight line. QOQU is one straight line. OQU is one straight line. Those 3 points lie on the same straight line. Otherwise, if one of the points doesn't lie on this straight line, then it will never create 90 degrees with VW. All the 3 points must lie on the same straight line in order that both OU will be perpendicular to VW and QU will be perpendicular to QW. Otherwise, one of either QU will not be perpendicular to VW or U will not be perpendicular to VW. Okay, so found out in conclusion that OQU is one straight line. This is OQU is one straight line from one side, but we already found out that QON is also one straight line. And from those two statements, we derive that in total NQU is one straight line. Line segment NQU must be also one straight line. If NQU is in one straight line, it means that NU is also a straight line. So NU is a straight line, but NU is a straight line that touches the circle at points N and U. Therefore, NU is a chord that passes for point Q that is the center of the circle, and any chord that passes for the center of the circle must be the diameter of the circle. Therefore, NU or UN, it is the same, is the diameter of the circle. Okay, NU is the diameter of the circle. Here, NU or UN, it is the same, it is the diameter of the circle. And we know that the diameter of any circle is twice as long as the radius, and the radius of this circle is b, therefore the diameter UN must be equal to 2b. Then I presented to you rule number 9 and we implemented rule number 9 in our drawing. So we found out that this line segment UN is the diameter of this circle that is equal to 2b. Okay? Then I presented to you rule number 9. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together must pass for their touching point. The center of the big circle is here at point O, the center of this small circle is here at point N. The straight line that connects their centers together is the straight line OM, of course. According to this rule number 9, the straight line OM must pass for point P. That is to say, OMP is one straight line, okay? OMP is one straight line. So we can implement rule number 9 in our drawing. Why? Because in our drawing, point O is the center of the biggest circle, point P is the center of the smallest circle, and the straight line OP connects the two centers together. At point S, the smallest circle touches the biggest circle. That is an internal match between them. Therefore, according to rule number 9, we get that the straight line OP that connects their centers together must pass from point S. That is to say, OPS is one straight line. OPS is one straight line. Again, OPS is one straight line. If OPS is one straight line, it means that SO minus SP equals to PO. Again, SO minus SP equals to PO. Okay, again, SO minus SP equals to PO. Why? Because SOP is one straight line. If SOP is one straight line, it means that SO is also one straight line. What is the definition of the straight line SO? The straight line SO starts from point O that is the center of the biggest circle, and that's the point S, that is the point on the biggest circle itself. This is exactly the definition of a radius. So OS is the radius of the biggest circle, is equal to x, so we can substitute OS or SO here in the equation by x. What is the definition of SP? Point P is the center of the smallest circle. Point S is the point of the smallest circle itself. Therefore, PS is the radius of the smallest circle, that is equal to 2. So PS equals to 2, or SP equals to 2, so we can substitute SP by 2. So in total, we found out that PO equals to x minus 2. Here, this line segment PO equals to x minus 2 units in its length. Then we extended the perpendicular ON by straight line. When we extend the straight line by straight line, the result is a straight line. So this is a straight line. If we focus on this side of the straight line at point N, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles from one side of the straight line is equal to 180 degrees. So which angles we have here? This angle is equal to 90 degrees plus the missing angle. In total, it must be equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees. Then we have tangent AC that is tangent to the smallest circle at point M. We join points P and M together by straight line. Point P is the center of the smallest circle, point M is the point on the smallest circle itself, therefore PM is the radius of the circle that is equal to 2. The radius PM is drawn to point M, that is the point of tendency of tangent AC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius MP. That is to say, this angle equals to 90 degrees, and this angle equals to 90 degrees. Then we do the construction, we draw perpendicular on the radius MP at point P. Again, we draw perpendicular on the radius MP at point P. So this angle equals to 90 degrees according to our construction. Then we extended the perpendicular until it touches the extended NO at point T. Point T is the touching point. So we created quadrilateral MNPT that has 1, 2, 3 right angles. 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Therefore, inside quadrilateral MNPT, we have 4 right angles. Any quadrilateral that has those 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral MNPT as a rectangle. We know that the opposite sides of rectangle are equal to each other. That is to say, MP equals to NT, but MP is 2, therefore NT must be also equal to 2. Likewise, in rectangle MNPT, MN must be equal to PT, but MN is 7 over 2, therefore PT must be also equal to 7 over 2. Then we define the length of line segment NO as H. Then I copied the green right angle PTO in the new page and we implemented this right angle PTO, the Pythagoras theorem. This is the right angle PTO that I copied from the original drawing. This angle equals to 90 degrees. PO equals to x minus 2, the hypotenuse PO equals to x minus 2 according to what we already found out. PT, we just right now found out that PT equals to 7 over 2. And in OT, the length of OT is ON plus NT. That is to say ON equals to OT equals to ON plus NT. That is to say OT equals to ON, that is H, plus NT, that is 2. So in total, OT equals to H plus 2. OT equals to H plus 2. So according to the Pythagoras theorem, in this right angle POT, PO square equals to PT square plus OT square. Repeat again. In the right angle POT, PO square equals to PT square plus OT square. PO is x minus 2, therefore PO square is x minus 2 square, plus PT square. PT is 7 over 2, therefore PT square is 7 over 2 square, that is 49 over 4, plus OT square. OT is h plus 2, therefore OT square is h plus 2 square. So in conclusion, we found out that x minus 2 square equals to 49 over 4 plus h plus 2 square. We open the brackets on both sides of the equation and found out that x minus 2 square equals to x square plus 4 minus 4x, that is equal to 49 over 4, plus h plus 2 square equals to h square plus 2 square, that is 4, plus 4h. Then the joint points O and C together by a straight line. What is the definition of the straight line OC? Point O is the center of the biggest circle. Point C is the point of the biggest circle itself. Therefore, OC is the radius of the biggest circle that is equal to x. ON equals to H according to our definition. And in the beginning of the lecture, we already found out that NC equals to 13 over 2. So I copy the right angle ONC, this angle of course equals to 90 degrees. I copy the right triangle according to rule number 7, of course. I copy the right triangle ONC in the new page and implemented on this right triangle ONC the Pythagoras theorem. The right triangle ONC according to the Pythagoras theorem, OC squared equals to ON squared plus NC squared. OC is x, therefore OC squared is x squared, and it is equal to NO squared. NO is h, therefore NO squared is h squared, plus NC squared. NC is 13 over 2, therefore x squared is 13 over 2 squared, it is 169 over 4. So in conclusion, found out that x squared equals to h squared plus 169 over 4. Now we can substitute x squared here by h squared plus 169 over 4. We did it, and we got that x squared is h squared plus 169 over 4 plus 4 minus 4x is equal to 49 over 4 plus h squared plus 4 plus 4h. Here we have h squared on both sides of the equation, so h squared will get cancelled. We have 4 also on both sides of the equation, so 4 also will get cancelled. And we have only 169 over 4 minus 4x, this is equal to 49 over 4 plus 4k. We subtracted 49 over 4 from this equation and found out that 169 minus 49 over 4 minus 4x equals to 4h. 169 minus 49 is 120, so in total this expression equals to 120 over 4 minus 4x equals to 4h. Again, 120 over 4 minus 4x equals to 4h. We added 4x to this equation and found out that 120 over 4 is 30, so 30 equals to 4x plus 4h. We took 4 as a common factor from those two expressions and finally found out that 30 equals to 4. Inside the brackets we have x plus h. We divided this equation by 2 and found out that 30 over 2 is 15 and 4 over 2 is 2, so 15 equals to 2 times x plus h. We divided this equation by 2 and finally found out that x plus h equals to 15 over 2. Then we found out what is the length of this line segment UN. From the drawing it is very easy to see that UN equals to UO plus ON. That is to say, UN equals to UO, that is x, plus ON, that is h, so in total UN equals to x plus h. So we can write here that from one side UN equals to x plus h. But from the other side, we have only found out that UN equals to 2b. So we can write here that UN is also equals to 2b, and from these two equations UN equals to x plus h and UN equals to 2b, we derive that x plus h equals to 2b. But we have already found out that x plus h, it is also equals to 15 over 2. So we can write here that x plus h equals to 15 over 2. And from this equation 15 over 2 equals to x plus h equals to 2b, we derive that 15 over 2 equals to 2b. We divided this equation by 2 and found out that b equals to 15 over 2 over 2, that is 15 over 4. So the radius of this circle, b equals to 15 over 4 units in itself, and the radius of this circle, a equals to 2 units. A equals to 2 and b equals to 15 over 4. Therefore the ratio b over a, it is b that is 15 over 4 over a that is 2. So 15 over 4 over 2 is 15 over 8. So we found out that finally that the ratio between the area of those two circles, b over a, equals to either 15 over 8, or in terms of numbers, it is equals to 1.875 units. Okay, thank you very much.